So we will see one more example for writing loops. We'll see a slightly trickier example, and we'll cover this over multiple sessions. So the problem is the following. We have to read a sequence of numbers until a -1 is read. -1 indicates that okay, the sequence has ended. And the question is, we have to output the length of the longest contiguous increasing subsequence. Okay, so that's a lot of words. Let's illustrate it with an example. Okay, let's say that the input is of the following numbers: 9, 2, 4, 0, 3, 4, 6, 9, 2, and then finally a -1. Okay, and we have to output the length of the longest contiguous increasing subsequence. So let's say, what do I mean by a contiguous increasing subsequence? Okay, so I say that 9 is an increasing subsequence, then the next number is 2, 2 is less than 9. Okay, so 9 and 2 cannot be part of a subsequence where the numbers keep on increasing. Okay, so 2 is the start of a new sequence. Again, the next number is 4. So 2 and 4 form an increasing sequence, so you can continue increasing the sequence. The next number is 0. 0 is less than 4, so you break the sequence there. And then when you look at the succeeding numbers 0, 3, 4, 6, 9, okay, they form an increasing sequence. And the last number is 2, which is lesser than 9, so the increasing sequence stops here. So these are the increasing contiguous subsequences. Contiguous means together, occurring adjacent to each other. So the largest or the longest contiguous subsequence is obviously 0, 3, 4, 6, 9. Okay, and the length of that sequence is 5. Let's take another example. 11, 9, 7, 8, 11, 12, 15, 15, and -1. Okay, so just to illustrate the point, 11 is greater than 9, so that can't be an increasing sequence. 9 is greater than 7, so that's another, the increasing sequence is just 9. But then 7, 8, 11, 12, 15, these are increasing. And I decided to stop here even though the next number was 15, because I am interested in an increasing subsequence. So 15 and 15 are equal numbers, so we break it there. So the longest increasing subsequence is 7, 8, 11, 12, 15, and its length is 5. Okay. So this is the longest contiguous increasing subsequence. So here is a basic property. Given any sequence of numbers, we can break it into a collection of increasing contiguous subsequences. For example, the numbers that the sequence that we have seen, so 9, 2, 4, 0, 3, 4, 6, 9, 2, and that the length of the longest increasing contiguous subsequence is 5. So we have to write a program to do this. Given a sequence of numbers, find the length of the longest increasing subsequence. Okay. So how do we do it? We do it in the way that we have been writing loops so far, like adding n numbers and finding their sum and so on. The idea was that you start from the first number and keep on adding the numbers until you hit a -1, at which point you have the sum. So the idea of this algorithm was that you start from the first and you keep reading, okay, until a certain condition happens. We'll adapt that idea to solve our current problem. So what we need to do is to keep track of the current increasing subsequence. Let us say that it is denoted by S. Okay. So before we get into the code, let's see how we will do it by hand. So initially the increasing subsequence is S, and let's say that it is empty. Okay. After you read 9, you have an increasing subsequence which consists of exactly one number. So S is 9. Now the next number is 10. 10 is greater than 9, so you extend S. Okay. Read the next number, 4. 4 is less than 10, right? So 9, 10, 4 cannot be an increasing subsequence. Therefore, you say that you break the subsequence there. Okay. So 9, 10 is a different subsequence. Now you start a new subsequence which is 4. So the current subsequence is just 4. So 0 is less than 4, so you break it there. The current increasing subsequence becomes 0. Read the next number, 3. 3 is greater than 0, so you extend the subsequence. S is now 0, 3. 4 is greater than 3, so the sequence becomes 0, 3, 4, and so on. Okay. So what are we doing here? We are reading the numbers integer by integer, and we are keeping track of the current increasing subsequence. Okay, so this is part of what we want to do. Now, in order to decide whether we should increase the subsequence, extend it, or break the subsequence and start a new sequence, what we need to do is we should remember what was the previous number we saw and what is the current number that we are seeing. So with two variables, we can say whether the subsequence should be extended or should be broken at this point. Okay. So if the previous number is less than the current number, then we should extend the subsequence. If the previous number is greater than or equal to the current number, then we should break the subsequence and start a new sequence. Okay. So extend the sequence means add 1 to the length of the current increasing subsequence and add that number to the subsequence. Okay. Reset means you start a new sequence of length 1. Okay. So from the description that we have seen so far, we need the following variables. We need C, which is for the current red number, P, which is the previous number that we have seen, and len, which is the length of the current increasing sequence. Okay. So we store the previous number into P, store the current length of the increasing subsequence into len, and read the next number into C. Okay. So if the previous number is less than the current number, so we take the true branch, in which case we extend the sequence. So the new number that we have read is part of the currently increasing subsequence. So increase the length of the sequence by 1, and now we move lockstep. So what we do is, so we are at a stage where suppose we have numbers 1, 2 and 3. Suppose P was pointing to 1, C was pointing to 2. So since 2 was greater than 1, we extend the sequence. After extending the sequence, we have to proceed and see what will happen with the next number. So when you do that, you can do the following. I will extend the current sequence by doing the following. I will now set P equal to 2 and C equal to 3. Okay. So this is the idea that we will advance both the variables by one number each. Okay, so that it is always true that previous is one number behind current. Okay. So I hope this idea is clear that in order to ensure that P is one number behind current, you have to advance both P and C. So assign P to C, this will advance P, and then read the next number, so that will become C. Now what happens if C is greater than or equal to P? Okay. Then the new number is not part of the current increasing subsequence, so you start a new sequence which is of length 1, and again do the same, assign P to C, which is advancing the pointer, and read the next number. Okay. So here is the method that we will follow in order to keep track of the current increasing subsequence. Now what is left is to find the longest of all the increasing subsequences that we find.